Okay then, hello everyone. It is Lil Wickens here with another math video, and I have 30 minutes until the dance class, so I am going to do this lesson very quickly. I swear, it'll be very short. Not like my long videos and the 16-minute one that I did yesterday. It's going to be quick. And I want to say, shout out to Carly for giving me an awesome intro song. Once I get a better editor, that I can put this video together and put a song on top of it, I will definitely throw that on there. So, intro song is fantastic. So, solving equations, that's what we looked at today. We looked at a different type of equations to solve. So, we were looking at, for the most part, equations that had multiplication, right? So, we moved from equations like x plus 3 equals 5, doing the opposite operation to isolate x for that one. We moved from equations like that towards equations that had multiplication in them. So 2x is equal to 6, something like that, an equation like that. And we were talking about solving that by, again, doing the opposite operation. So what is being done to x here? X is being multiplied by the 2, because when I have that number next to the variable, it means multiplication. So x is being multiplied by 2. So in order to isolate x, because that's always what we're trying to do, we're trying to get down to this point where we just have x on one side of the equation. In order to do that, I'm going to do the opposite of multiplying by 2. So I'm going to change this side of the equal sign by dividing everything on this side by 2. So I've put myself into this equation. I've said I want to divide this by 2. I've changed this side, I must change the other side by the exact same amount to make sure that this equal sign stays true. I don't want to break the law. That's kind of a funny way of putting it that I've been saying, is I don't want to break this rule, this law that says both sides have to be the same. So I've divided this by 2, I divide this by 2, and I end up, this undoes that multiplication, and I'm left with just the x, just the variable. 6 divided by 2 will be 3. So I can check back in the original equation. If x equals 3, does that give me 6? Yes, 2 times 3 is 6. So that was the correct answer. So this was an easy little question here. We can get more complicated with different numbers. I could choose, what's an interesting one I could do off the top of my head? Well, I could go, how about 125 is equal to 25q. Something like that. 25 multiplied by q. Well, what's q going to be? I have no idea. But we can do the opposite operation and play with this equation to figure out exactly what it has to be. And again, I want you to show all this work every time you solve questions like this. I want you to show me the opposite operations, the opposite things you're putting into this equation to get down here, because it'll really train you to get used to doing this, which is important for the harder equations we'll get to be working with. So multiplying by 25, I'll divide by 25, like that. These will cancel out, and I'll just be left with q. 125 divided by 5, or 25, that will just give me 5. So q equals 5 here. And you can maybe use a calculator for that if that's kind of tricky. So those were the equations we were looking at today. Moving forward, what are we going to look at? We're going to look at equations that combine that multiplication idea with addition and subtraction. And a good thing to keep in mind as we move forward is BEDMAS. Brackets, exponents, division, multiplication, and then addition and subtraction, where these happen in kind of the same stage of BEDMAS, remember. So multiplication and division are on the same level. So if I had something like, let's choose 4x plus 1 is equal to 17. So how am I going to work and pry away these numbers around x so that I end up just with x equaling something? Because I want to isolate this. I want the equation to tell me exactly what x has to be rather than me guessing myself. So x is being multiplied by 4, and we're also adding this 1. So those are the things I want to get rid of, the 4 and the 1. So I need to undo them by doing the opposite things. I'm going to need to divide by 4 at some point, and I'm going to need to subtract by 1. Now, I'll tell you this right now. When we are solving something, we often want to use BEDMAS in this order. But when we're undoing things and going back to the original variable, we want to go backwards through BEDMAS, which means I'm going to start with addition and subtraction. So to get back to x, I'm going to get rid of this addition first. We want to work our way into x, and this 1 is further away from x. That's how I like to think about it too. So we're going to do the same thing. We're going to do the opposite operation, and we're going to take away 1. I've changed this side, so I need to take away 1 from this side as well. Positive 1 or plus 1, take away 1, that just gives me 0. So from here I get 4x is equal to 17 minus 1 is just 16. And now we're back to something we're more familiar with. And from here, all I have to do is undo this multiplication by 4. I'll divide by 4 on this side. I have to do the same on the other side. I've divided this side by 4. That gets rid of this multiplication, and I'm left with just x. And then 16 divided by 4, that's just 4. So my answer should be x is equal to 4. Is it? Let's see. If we put that back into here, we substitute that back in. Is 4 times 4 plus 1 equal to 17? Well, 4 times 4, that equals 16. And then if I add 1, 16 plus 1 is 17. Yes, it is. Perfect. So that is the answer to this equation. It's really important that you show all these steps. That's how you'll get full marks, and that's how you'll get comfortable with solving equations like this, because we get much more challenging numbers the higher up you get, and just this process is really important. Once you get into even more complicated equations with more variables or other types of things instead of multiplication and addition and things like this, when we get into more complicated things. We won't look at it in this unit, but we can also have, one of the questions I had in the booklet was 15 is equal to, I had one of my classes today joked that I had a memory for the things that were, a good memory for the things in the booklet, but I don't know, I just remember them. I think it was either 5 or 3 is equal to 15 over a. It was something like that. So we can also have division in an equation, and the same thing happened. The same game is played. We still want to get a equals something, but this one's a little harder. How do I get a all by itself when a is being divided? How do I get a all by itself? What can I do to this equation? Because I can add 1 to both sides. I'll do it in the way we're used to doing it. I can add 1 right here, add 1 right here, but that's not going to help me at all. 15 divided by a plus 1, that's not going to help. I could multiply by things, I could divide by things, I don't know, what could I do? How could I get a all by itself? So it's important to follow these steps so that we can get more comfortable with it. I want to make this a short video, so I'll end it here. But I want to do one more quick equation rather than, I won't really draw it out, but I'll do the steps for another one. So why don't I go 5x plus, let's do a subtraction. Let's do 5x minus 3 is equal to 17, like that. So, and I'll use a different variable. I'll use, y. 5y minus 3 is equal to 17, because it doesn't matter what this is called. I want to get y all by itself. I want to isolate it somehow. I'm going to do the addition and subtraction parts first. So I'm going to add 3 to get rid of the minus 3. I have to do it to both sides. So that cancels that out, and I'm left with just 5y is equal to 17 plus 3. That's just 20. Lastly, 5 multiplied by y, I want to undo that, so I'm going to divide by 5. But I have to divide the other side by 5 as well, and I end up with, when those cancel out, y is equal to 20 divided by 5, that's just 4. And if you put that into the equation, you'll see that that is indeed what the variable is supposed to be. So, that's the lesson, and I can't remember who was saying it, but they told me a way to end the video, so this is Lil Wicken signing out, and I'll see you later.